So I think this is all of us, so I guess we should start now. I'm going to start myself. Screen one. Okay. So as you already know, this workshop is called Advanced Secondary Analysis of Large-Scale Assessments in Education, and we are going to have a discussion of methods. As we already said, this workshop is the people who is going to be talking to you, telling you about these methods is myself, Andrés Sandoval, Diego Carrasco, and Daniel Miranda from Centro de Medición in the University of the Catholic University of Chile, and Pamela Inostroza, who is in KU Leuven. So let's get started. We have around a bit more than 2 hours. I'm going to give first a brief introduction about what is international large-scale assessment data in general, and a few words about the International Civic and Citizenship Education Study, which is the one that we're going to be using for the examples. Then Diego Carrasco is going to talk to you about how to prepare data for M+, which is the software that, again, we're going to be using for the examples today. And then he will continue with an example analysis of latent class analysis using civic education data from the ICCS study. And Daniel Miranda will continue with an example on structural equation models. As we already said as well, you can post your questions in the chat in case you have them. We are not that many people, so we were thinking we would compile all the questions for the end of each section, but because we are not that many, I think it is probably makes more sense if you want to, you have a question, just raise your hand using the tool that Zoom provides, and we can stop for a moment and try to address the question. If it is something more complex, or if you don't feel like doing the question speaking, just put it nevertheless in the chat, and we will come to them when we have in each of the breaks. So,
Andres, may I say something? Sorry.
Of course.
You will notice that in the reaction box, you cannot actually put up your hand. So yeah, you can use any other symbol or just unmute yourself like I just did right now. I think that could be better if you want to speak directly. Sorry for the...
No, thank you very much. I hadn't noticed that you cannot do that.
We discovered earlier today, so it's good to know.
Yeah, thank you very much. So yeah, you can tell us in the chat that you want to ask a question, or you just wave at us, and we'll try to give you the word. Okay, so yeah, around 30 minutes for each type of analysis, for each example, and around 30 minutes for questions at the end. A bit less probably, because we already took some 10 minutes from the introductory part. So I'm not going to make this very long, because most of you already know the basics about this, but there are some things that we have to discuss in order to be on the same ground, having the same understanding of some basic elements of what we're going to be talking today. So this introduction to the international large-scale assessments. The first thing to say is that I think most of you, if not all of you, know, of course, the data from PISA. PISA is probably, or surely, the most popular international large-scale assessment, but it's by far not the only study. We have many different assessments now. Everything started back in the 60s with the IEA, which is the International Association for the Evaluation of Educational Achievement, and they were the pioneers in this area. It started as a collaboration of academics. They met in a conference, and they thought that it was a good idea to apply the same test to samples of students in different countries to be able to compare. From there to now, many things have happened. They started first with these preliminary studies, and then in the modern age of international assessments, they started with TIMSS and PIRLS, which are their two flag studies. TIMSS is about mathematics and science. PIRLS is about reading literacy. They have been running since the mid-90s. And then later on, they have the ICCS, which is the study that we're going to use today, but they have some other, many more actually. They have other studies to assess mathematics teachers or computer literacy, early education, and some others. This is very interesting. If you go to their website, you will see all what they have. From the IEA, we can say that one of the, as a spin-off, PISA was born. And PISA is a study that combines both mathematics, science, reading, literacy in the same test. But they have a main subject in each cycle every 3 years, so it is rotating. And then after PISA, which started in 2000, the other studies were launched. For example, PIAC, which is also known as the PISA for Adults, is another study, an important study done by the OECD. And they have TALIS, which is the Teaching and Learning International Survey. This is a survey for teachers, also very, very large study. More or less at the same time, but derived from these two organizations, these are probably the two main organizations doing global studies. What happened is that some countries have started to question whether it makes sense to compare countries that are very, very different, let's say Peru and Sweden, or Nigeria and Thailand. And they started to question whether it makes sense, whether we can learn anything from countries that are so diverse. And with this idea in mind, UNESCO was the first one to start sponsoring or encouraging some regional studies, international but regional studies. So the oldest one is TERCE, which actually started at the same time as PISA. And this TERCE is a regional study, a regional comparative and explanatory study for Latin American countries. And they thought that it makes sense to compare countries in the same region because, for example, in Latin America, they speak the same language. They have a similar history, they have a similar education system, they have a similar economic development, similar culture. So it made sense to have a study that is especially designed for them, and they have been doing it since then. No? TERCE is the third study, but now actually I should have written ERCE because this is they are now about to release the data for the fourth study, in which, by the way, Diego Carrasco is working on. Well, we have this study, but they also have other regional studies like SACMEC, which is the Southern and Eastern Africa Consortium for Monitoring Educational Quality. And then other international organizations came into play, like the World Bank supporting PASEC, which is basically a regional study in Africa for French-speaking countries, or PRIDI, which is a study in Central America for early childhood education. Now, more recently, UNICEF has also come into play with some regional studies, one in the Southeast Asia. It's called the Southeast Asia Primary Learning Metrics. And they also have PILNA, which is the Pacific Islands Literacy and Numeracy assessment. For those interested in academic tourism, this is your study. So you can travel to all these nice islands in the Pacific. What else? What do these ILSAs evaluate? Of course, at the beginning, it was only mathematics, reading, and science. But as they have evolved, they are now evaluating many different things. We have, as you know, mathematics, reading, and science. These are the main things, the first things that were started to evaluate. But then we also have some studies like the study in Southeast Asia and ERCE. They evaluate writing to not only reading, but writing literacy. The study that we're going to use today for the examples uses information about civic education, but also about attitudes and beliefs towards different things, no? Like attitudes and beliefs toward equal rights for immigrants, for men and women, for ethnic rights, ethnic minorities, etc. PISA has also been, let's say, playing around or evaluating other areas like financial literacy, and in the most recent edition, global competences. As I already told you, there are some other studies in the IEA, for example, evaluating computer literacy, And there are more things, no, that you can explore. Apart from evaluating this, these are the things that they evaluate, what is the test about. But apart from that, all these studies collect a wealth of background information. So they evaluate learning outcomes, but also they evaluate the context in which learning happens. They collect, in most cases, information from students and their families in some cases. They collect information from teachers. They collect information from schools or school principals. And they also compile information about countries. So when students, for example, they collect data like sex, age, grade, whether they belong to an ethnic group, what is their immigration background, socioeconomic status. In the case of teachers, is also sociodemographic information, but also they collect information about professional development needs and what kind of professional development they are receiving too, teaching practices, teaching beliefs. In the case of principals, they collect information about the principal, him or herself, sociodemographic information, but also about the things that happen in the school, like school climate, bullying, parental engagement, etc. And about the countries, I mean, this information is not really collected by the survey, but is easily, can be easily merged with this information. No? And they don't collect it because it's only one variable per country. No? In general, it wouldn't make much sense. But if you want to do this kind of analysis, it is possible, and most or many researchers do include variables like GDP, Gini, or HDI, Human Development Index, level or state of democracy, cultural indicators, happiness, and you name it. In general, on average, each of those studies that I was telling you about collect around 700 background variables. So pretty much anything that you need to know about the context in which learning happens, it's going to be there. So you just have to look at the frameworks, look at the data set, and you will have really a wealth of information that you can use to produce different hypotheses or to test different educational, sociological, political hypotheses. If you want to have a good overview of all international large-scale assessments, there is a website that is sponsored by the IEA, but includes international assessments, even the ones that are not run by the IEA. So most of actually all of the studies that I told you about, they're included here. And they give you, in one place, they put all the information that you need. For example, the data set. Each study has a different way to get the data set. Sometimes you can just go click on a link and download it, but sometimes you have to request access to the data set. But well, in this, and sometimes it's not so evident or so easy to find the link to actually get the data. But this website is going to help you to do that. It's also going to give you facts about the studies, who's organizing, what is the sample, what countries participate, et cetera, and what are they evaluating, what background information is available, and many more things. Now you can access all the international reports from all the studies from this website. It's going to give you information about the organizations that are running the studies, additional materials, and even papers that are published in peer-reviewed journals using the different data sets. So it's a very good starting point if you are interested in this area. Now, very quickly about the study that we're going to use today. It's called the International Civic and Citizenship Education Study. And this is an old study, one of the first ones. It actually, the first is the first study that was run by the IEA in the 70s in only 10 countries, included a test on civic education. Later on in 1999, there was the first Civic education study in which 28 countries participated. In 29, we had 38 countries. 2016, which is the data that we have available and the one that we are going to use today, has 24 countries, and they are now recruiting countries. They have started the process. Actually, they should be collecting data sometime soon in 2022, next year, is going to be the next ICCS. We don't know yet how many countries we are going to have there. Something that is very interesting and very characteristic of this study is the regional components. So as I said, one of the criticisms to these global studies is that it's very difficult to compare across countries that are very different. But in this case, the ICCS has blocks of countries which have a component in the instruments that those are questions that are exclusively made to students in Europe, for example, and those are questions that have to do with the problematics, the context of Europe, but also in Asia and Latin America. We have very interesting things in these regional models. In Europe, I think we have one of the issues that was prominent was immigration. In Latin America, we have issues about democracy, about corruption, about different things that the countries, the representatives of the countries from the different regions thought it was relevant or important to include in the tests. So they have this flexibility, and they also have these regional reports based on this specific data for each region. The objective in general is to compare the civic and citizenship education in the different education systems. And also they want to measure trends from Civic 99, which is technically is the one that is comparable with 2009, 2016, and will be comparable with ICCS 2022. And also the idea is also to address new challenges in civic and citizenship education. If you observe the frameworks of the studies, the different cycles, you will see that they are, or they try to adapt to new challenges that we are facing in society. And another important thing to say is that they have two main domains. One that is cognitive, and the cognitive part is the test. And this is about, evaluating the knowledge and understanding of concepts of the civic and citizenship concepts of the different countries. And probably more, well, from my personal perspective, probably more interesting or very, very interesting is the affective domain, which is developed around beliefs, attitudes, and behaviors, or intended behaviors that have to do with civic participation, with citizenship participation. And this is well, very interesting to contextualize the knowledge and contextualize what is happening in the different countries in terms of civic and citizenship education. Yeah, the documentation, you can have links in the presentation or in the ILSA Gateway, which is the website where I told you can have information from all studies. Most of these studies, specifically ICCS, but most of them have a framework. So what are the concepts based on which the assessment was built? Why do they ask what they ask? And why do they have this information in the background questionnaires? How is it expected that the information that is collected in the background questionnaires is somehow related, or why should it be related with the cognitive part, for example, or the relationship among the different components of the background questionnaire? They also have international reports and regional reports. A technical report that is going to give you all the details that you want about the different stages. How was the sampling done? How was the assessment designed? How were the scores scaled? How are the background constructs, the scales, the background scales produced? Everything that you can think of is going to be there. How do they construct the sampling weights? How do they construct the replicate weights? Everything is there. It's like a brick. It's like 700 pages of pure fun. And you also have a user guide. A user guide that is going to tell you how to use the dataset. Where can you download it? How can you analyze it? The IEA has a software that is very useful to do some very basic analysis, descriptive analysis, and up to regressions and logistic regressions you can do with that software. And the user guide has a full chapter on where can you get this software, which is free in principle, but you need SPSS or SAS to run it, and how to use it. So it's very useful as well. They have the database, they have infographics, they have in general all the information that you will need. I didn't tell you, but I used to work for the IEA. One of the things that I was doing is answer questions from people who had questions about how to analyze the data. And I can say like 98% of the responses were go to the user guide in the page 458 and there is your answer. So practically any questions that you may have, it's already in this user guide. Of course, you're not expected to read it from beginning to the end, but if you download the PDF, which is free and publicly available, you can easily find answers to your questions or doubts that you may have. Finally, something that is important to say, and this is probably why we have this workshop. I mean, structural equation model, latent class analysis are not the newest statistical techniques, but they become complex when the data that you want to analyze is complex too. Why? You will hear a lot that the data from international large-scale assessments is complex. And when they say that, what they mean is that they have a complex sample design, and they also have a complex assessment design. When we say complex sample design, what we mean is that the sampling strategy is multi-stage stratified cluster. It is multi-stage stratified cluster sample design, which basically means that it's not a simple random sample. It's not that you have the names of all the students, put them in a hat and select 5,000. What you actually do is to select first a sample of schools, previously stratified, and then within the schools that you select a sample of, in this case, of classes, and then you take all the students that are in a selected class. That in practice has a consequence, and the consequence is that you have to use sampling weights to balance the sample and the population, but also because of the multi-stage stratified design, you have to account for that. And you do that by using multi-level models or hierarchical linear models, or replicate weights. Replicate weights being the same as is a form of resampling method, or bootstrapping, many people know it like that. The method that they use in the IEA, or that they provide tools for, is replicate weights, jackknife replication to be more specific. So this is for the complex sample design. For the complex assessment design, what they mean is that not every student is assessed and not every item is answered by every student that is chosen. So you have a sample of students, which we already said, but then you have a sample of items, which means when you want to analyze, when you want to evaluate civic knowledge, the test would be so long that one single student would take around 12 hours to answer the test non-stop. Because you cannot do that, what you do instead is that you take a sample of the items, a part of the test, and give it to one student, another part of the test to another student, and so on and so forth. So among a group of students, they answer the full test. But then what happens is that you have a missing data for every student. Every student has missing data, and you have to impute this data. This is known as the plausible values, which in practice is nothing more than having multiply imputed data sets for the cognitive part. But that also has an implication when you want to do the analysis. And in both cases, the complex sample design and the complex assessment design, the replicate weights or the plausible values, what happens is that you have to add something else to the calculation of the standard error. So so you don't underestimate these standard errors. The formula is there. You don't have to learn it, of course, or you don't have to solve it by hand. But the software, in this case, M+, is going to take care of it for us. And now I think this is the last slide. Some things that we have to consider before we start analyzing data is that this is cross-sectional data. So this is from one specific point in time. So therefore we cannot, we know what the students, what happened, what is the context of learning when the assessment was made. We don't know what happened before, we don't know what will happen after, and things may change. So we have to consider that. For this reason, it's very difficult or practically impossible to establish causal relationships. However, we can have a very rich description of what students know and the context in which this learning occurs. As I said, you have 700 variables to describe this context. Yeah, another thing that to consider is that all students, teachers, principals, they report their perceptions and beliefs, which is not necessarily the truth. So they're going to say what they think, what they feel is not necessarily the truth, because we have things that biases like social desirability. We can have overstatements that are more pronounced depending on they're different in different cultures. We have contradictions too. So we have a number of things that we have to consider, but those are limitations that are general for any type of study based on a survey. And now this is all from my part. I'm gonna give the floor to Diego to continue with the, well, first how to prepare the data and then the first example on latent class analysis. If you have any questions about this, well, Diego is sharing his screen. Please just go ahead.
Okay, give me a second. I'm going to close my window to avoid any other. There we go. Can you hear me well? Okay. What I'm going to present is how is to try to address 5 different problems that we may encounter when we are dealing with data from large-scale assessment. The first one is that we're going to have several files, and we want to have them in a single file to make, for example, a data model that compares between countries. And the later problem that we will have after a few other loops that we need to resolve is how to export data for how to export data when we need to model when we need to fit any other latent model outside the original environment that we're working with. What is it? So for starters, what we can say is that if we picture the full set of stages from data collection to presentation of results, we need to start by thinking that any large-scale study start by having participants with a certain design. Then we're going to have a set of specific instrument with which act as a stimulus to participants so they can give us responses. Then we have a data entry process in which these responses are recorded or stored. And finally, we need to use those response files that come from a data entry process and import them in a certain way. Wait, I'm going to check if my microphone is okay. Okay, yeah, it's okay. So the presentation for the current presentation, what I'll be talking about is once we have the response files that are the public data files that an agency will release, how we cover the process from importing data to exporting a prepared data file for implementing a certain statistical model. So we're just going to focus between data importation to the exportation of a prepared data file for statistical modeling. So if we try to think about this stage that I will consider this process as an iterative process. So every time that we work with large-scale assessment data, we will take up the original data files till we build up a statistical model. And we're going to do these several stages several times. Either this be because we would make a mistake and we need to amend it, or because we are going to do more than one model. It's really difficult to prepare a single data set for every possible statistical model. So the most likely scenario is that if we're going to fit, for example, an IRT model or a latent class analysis or a structural equational modeling, is that we will need to prepare data for each of those statistical models. So if we think this iterative process as a set of problems, I would say that a selection of the most common problems between importing to exporting data will be first, how to deal with the fact that we will have several files. This varies between different studies. Some studies, they will give you an already merged file. So there, in a single file, you will receive all the responses out of the students for the text, for example. And we will only need to merge those files with the school data. In the case of ICCS, this is not the case. What they give you is 24 files for the questionnaire, for the background questionnaire for students. And so you're receiving one file per country, per instrument. So for example, if the study is collecting data from teachers, then you would have an instrument, an informant, and then a country. Then you can multiply how many files are you going to receive. In the case of ICCS 2016, I think it's about like 139 in total. The second problem is that once we have, once we created like a merge file, so a single object in which we are collecting all the responses out of the students from all the countries from a single study, is how can we build up like a friendly document? So how can we know what is within the file that we have created? So we're going to address that with a few lines of code. Then the third problem is how to deal with the survey design. But everything about that Andres was telling you about before regarding that the students that participate in the study come from a complex sample design. That means that we're going to have several vectors within the data frame. That means several variables that express this complex sample design. When we are in the scenario that we want to compare, for example, two countries at the same times in a single model, that means that to take advantage of the survey design, we need to make some sort of tweaks. Either this be that we need to scale up the survey weights, or to be sure that the stratification variables are in a correct manner. Because not all statistical software would assume in a correct way the expected properties of these variables. Then one of the most common problems, but I would say the fourth problem in this framework, is to consider the response interpretation. That means that most of the time when you have a paper-based studies, the data entry values over the responses of the students are assigned from left to right. So that means that not always like a higher value would mean like a higher frequency, like a higher endorsement, or like a higher agreement. So we may need to change those values into values that are interpretable for our purposes. And finally, the fifth problem to finalize this workflow is the transferability of the data frame that we can create. So how easy is that we can share the data frame that we created either to another user that we are going to collaborate with, or for ourselves in the future. So the main point is that once we have done all this work, how friendly and how easy is to transfer all the work that we have done so we can make use out of it in an easy way. To illustrate this, how to address these different problems, we're going to use R. In particular, we're going to mainly use libraries from the tidyverse. So these are like friendlier libraries and commons. And as a complement, we're going to use an experimental library that I'm developing that resolves many of the issues that you would need to do to, for example, to scale up survey weights. And I mean, one of the advantages of using this experimental library is that all the specialized functions are fully documented. So for example, one of the most, I would say like odd code is how to scale survey weights for multi-level models. If you go to the repository of this library, you can open up the code that I'm using, and you can even find the reference from which I'm taking on how to build up these scales. And a warning that I can give you is that the way that I'm building up this workflow is an entirely opinionated analysis. That means that this is not the only way to do it. This is just a way to do it, and I can argue that this is a reasonable way to do it. But at the same time, this means that you can find different ways that would suit your needs and purposes probably in a better way. So the first problem is that we're going to address is how to import many files. If you go through the standard way of the trainings that the IEA provides, you will need to use IDV Analyzer. What IDV Analyzer does is that it's going to read your computer, and if you have SPSS installed, it's going to create several macros that would allow you to merge all the data files from different countries. So the issue is like, what happens if you don't have SPSS, or what happens if you don't want to have it? Then one alternative is to use an open source and a freely available statistical software like R. And what we need to resolve is how to do this in a tidy manner, how to do it in a friendly way. Because the other option would be to write a single line of code per each of the files and then merge them all together. And probably that would be a little bit tedious, and at the same time, it's going to be cumbersome and prone to error. So one way to try to address this problem is that what we need is a function that can be repeated over a list. So the following code that is at the right side of the handout, first what is establishing is an object that says where you have the data files located. Then in a second step, it's going to go to that location and is going to search for all the files that fit the following pattern, the ISG. As Andres was saying, most of the information from ICCS is contained in the technical documents. And if you go to the technical documents, I think it's in page 24, they say what are the common features between the data files that they provide for the study. So all the files that contain the responses of the students from the background questionnaire, they start with the letters ISG. So out of the 139 files, we know that these are the only files that that are collecting and storing the responses of the students to the background questionnaire. Once we have this object, which is just a list of all the locations of these 24 files, what we need to have is something that can import all of those files one by one, and then give us a single object. And this can be done by the following code. And so this is a functional coding, and what it's doing is that these are the lines that can read a single SPSS file that is located in some logical folder within your computer. And what this function is doing is that it's reading one by one all the 24 locations, then applying the the having function to read SPSS files. And then at the end, because this is a df function, instead of giving you a list, it's going to give you a full data frame in a single line. So we have just resolved the first problem, that if we have many files, there are ways that we can work around with code to avoid this idea of importing files one by one. The second issue is that now we already have a single data frame in which all the responses from the student background questionnaire are contained. But now the issue is, how can we create like an informative file? One way to do an informative file is an easier to open file. That means that if we send it, for example, out of an email, or if we share via Dropbox to another user, is that this file that we're providing can be read by any other user. And one solution is to create a simple codebook. A simple codebook is just going to contain, for example, the list of variables, the type of variables that the data frame contains, and like a short description. When we create a data frame, for example, either with SPSS, Stata, SAS, or any other statistical package, there is no guarantee that any other user could open those files unless they have those statistical package installed in their computers. So even if we, for example, are I don't know, like a frequent user of R, that means that every time that we want to see the content of a data file, we will need to open up R and create a code just to check what is inside of this data frame. So I would say, like, a good practice recommendation every time that we're working with large scale assessments, that every time that we are going to import the original data from our large scale assessment, and we are going to save these merge files, we could create like a simple codebook that accompany these files. So every time that we are sharing these kind of folders that contain these data frames, you can easily open it up, for example, an Excel spreadsheet that give you like a quick description of the information that is contained in the merge file that we created. So an easy way to create like a codebook is to use the experimental library that I'm developing, and we repeat the same object that we created before. That is, we're just telling R where our files are located, and we're going to use these following lines of code. The variables table function, what it does is it's going to read the data frame, and it's going to extract the descriptive information out of the content of the data frame. So it's going to retrieve the variable names. It's going to create like a single column of type. It's going to extract also like a sample of values that you can see, and the labels that you would see, for example, in this kind of files if you open them up in SPSS or Stata. And then we're just going to use another library that is OpenXLXX, which is a library to open and create Excel files. And we're going to store this table within the same folder in which we are going to save the merge files of all the responses of the students to the background questionnaires for every country. This is a little bit more cumbersome, and this idea of having common names for survey design variables is under the assumption that you may need to work with different large-scale studies. So the scenario for which we were working on and that we came up with this solution was in a scenario that we I don't know, let's say on Monday we were needed to be working with PISA, on Tuesday I would be needed to working with ICCS, and then on Wednesday we will be needed to work with Teams. And this was a real scenario that we were working with Andres, in which we were making several comparisons between countries over different indicators for the SDG indicators comparison initiative from UNESCO. So the issue is that most of the large-scale studies would have a collection of clustering variables that express the survey design. The idea here is that most of these objects are common, but they will have specific names for different studies. So for example, the total survey weight in PISA doesn't have the same name that would have the total survey weight in ICCS. So if we're going to constantly analyzing data from PISA and from ICSS back and forth, one way to address this issue or to deal with this scenario is to have a common name for all the main objects of the survey design. If we do this, the advantage of having a workflow that uses this strategy is that it allows us to create transferable code that is applicable either to ICCS, to PISA, to TALIS, or to any other large-scale assessment that shares the same features. So what we are calling clustering variables are just the unique variables that identify an observation. So for example, a student is within a classroom, and that classroom is within a school, and that school is within a strata. And because most of the ICCS, most of the IEA studies uses jackknives, a part of clustering variables, they would have a replicate unit or like a primary sampling unit. The primary sampling unit is the clustering variable that is joining together a several set of observations that are going to be corrected in a certain way using the survey design. In actual terms, what it happens with a few countries that don't have enough cases within a school is that they would need to merge them together in a pseudo school. So at the end, when you're working with the estimation with a jackknife, these pseudo schools are hidden between the jack zones and the jackknife replicated weights. So using the information from the jack zones and from the replicate weights, you can create these primary sampling units, which are the cluster that the jackknife is using to correct the standard errors. And this is mainly applicable for countries that are too small. For example, this is the case of Luxembourg, but this wouldn't happen for larger countries such as Mexico, in which you have like many schools. The second collection of variables within the survey design that we need to treat are the survey weights. Most of the studies from large scale assessment, what they would give you, or that will be more obvious to identify or to spot, is the total weight. So the total weight is the vector of variables that we can use to expand the observations that we have to make inferences to the population. But the scale of this variable is going to be in the expected population of the design. So given the sampling frame, let's say, I don't know, a country has an expectation of, or a population of 5,000 schools. So that means that the total weight is going to expand the selected observations to those 5,000. So if in comparison, we have another country that has, I don't know, 80,000 schools, that means that the survey weight is going to be scaled to expand the observation to that total number. The other weights that we might need for modeling are the within school weights and the school weights. So this is especially the case for multi-level modeling using pseudo-maximum likelihood, in which we estimate a random term that will represent the latent mean of the schools, but at the same time, we want to include in the estimations the survey design. So that means that the probability of selection of schools are going to be conditioning where are we going to locate the latent means that we are trying to fit with a multi-level model. So if we want to create those kind of models, we will need then to build up the student weights within the schools and the school weights. In the case of ICCS, this is an easy task because you can go to the technical report, and in a specific page, they're going to tell you what are the different components of the survey weights that you need to use to build up the within school student weights and the between school school weights. This is not the case, for example, with PISA or with TALIS, in which you might need to retrieve the school weights from another data file. So bear in mind that the generation of the within and the between school weights, they heavily require that you have like a thorough reading or revision of the technical documentation out of the large scale assessment that you're working with. Finally, the Senate weight, most of the time this is already provided by the public data files, but you might need, it's possible that you want to have it in a different scale. I think, if I'm not mistaken, most of the large scale studies, they would give you Senate weights that are scaled up to 500, but if you can also scale it to a different number, and they may tend to work in a similar fashion. The Senate weights are crucial when you want to merge two different countries that they have sampling frames of different sizes. So let's say that we want to compare, I don't know, like Paraguay and Mexico, which are like entirely different in size of the amount of schools that they contain. So if we put them together with the same weight, and we just run either like a multi-level model or like confirmatory factor analysis or an IRT, our estimates are going to be distorted, given that one of the countries have weights that are much larger than the other country. So if we scale them up, that means that the sum of the weights are going to be fixed to a specific number. Then the two countries are going to be balanced, and then each of the two are going to be contributing to the statistical model in an equivalent way. And finally, here are the generation of the scale weights for multi-level models that can include the survey weights within their estimations. The most common versions of these scale weights are the normalized within school weights and the effective sample size within school weights. In the references of this presentation is the reference to Stapleton from 2013. Stapleton makes a thorough revision of what are the features of these two type of scale weights and when these are more convenient than the other. With larger samples, they tend to behave in a similar way, but there are like edge cases in which one of the two may be more convenient than the other one. So this is like a few lines to take up the merge that we created before and apply all of those. We're addressing all of the previous issues that I mentioned. So the first one, the first few lines, which are these ones, are generating the clustering variables that will have the features that we need if we want to make latent variable models that include more than one country, and at the same time take advantage of the survey design. Then the following lines are there to deal with the survey weights. So the first one is just creating a generic name for the total survey weight. And then the other one are creating the raw within school weights and between school weights. Then the next line is just to create a Senate weight that is going to be called double QS. And then the final lines are just there to add the multi-level weights that we will need to use if we want to do multi-level modeling, including the survey weights. So for now, in the code that I'm showing you or that I'm proposing within this framework, I'm just giving a solution of how to build up, for example, like a unique ID for all the schools across all the countries. But the main point that I'm trying to say within this workflow is that to take advantage of the survey design, we need to be sure that the clustering variables behave in the way that they are intended to. The main point here is that the original ID school from ICCS, for example, can be repeated between between countries. So that means that, let's say in Colombia, there is a school that is called 0001. And then in Netherlands, there is also another school that is called 0001. So if I put Colombia and Netherlands in the same, in a same table, and then I submit that table to a common multi-level package or multi-level library, the software may not know that the school 001 from Colombia and the school 0001 from Netherlands is a different school. So we need to tell the software that these are two different schools. One way to do that is to generate a specific ID cluster that we can defend, or that we can show that this is different across all the countries. So the following lines that are here are checking those assumptions. So this, for example, this line, what it's doing is to check that our stratification variables that we created that are unique across countries are actually unique across countries. If we fail to create a stratification variable that suffices this assumption, then when we're feeding models using the survey design, the result that we're going to get might be a little bit distorted. In the case of the stratification, maybe this might not be so so drastic, but the most likely scenario is that we're going to lose statistical power. The main advantage of having more stratification variables is that we're going to reduce the size of the standard errors. So sometimes this is something that we need to be careful about. And in the case of the clusters, so this is the identification of the primary sampling unit, here is way much more drastic. If we're trying to create a multi-level model and we have the wrong assignment of students to schools, then the latent means that we're going to create or fit over the data are going to be entirely wrong, because we will be merging students from different schools into the same cluster. So these are just two functions. Probably the most simple one is the one that can create Senate weights. So here the main advantage of this function is that you can create Senate weights over any type of data frame. So even if you have a subsample of a large scale study, you can still create these scale up weights. And the only information that you need to do this is, is the original weight and the vector of the countries that you're going to be over which you're going to be creating these Senate weights. For the generation of the large-scale assessment weights for multi-level modeling, the amount of arguments that the function is requiring is a little bit more cumbersome, because it's requesting all the critical clustering variables and all the weighting variables for each country. So this is to be sure that if we're going to create 4 different variables for survey weights for students within schools and between schools, we need this kind of information to be sure that the assignment of the scale weights that we are generating are the correct ones. And as I told you before, because this is is an open library, if you have doubts of or you want to check for reference of how these weights are created, you can go and check the links of the original repository of this function and check all the references from where I'm taking the information to implement this procedure. But most of the explanations come from a presentation from Sofia Robesquet, and most of the documentation that is present in ICCS technical documentation from ICCS 2009. So this is an applying example. So the idea here is that for the case of the SDG, we needed to classify students regarding their endorsement of civil rights. In this case, in the SDG framework is labeled as freedom of speech, but within the literature, this scale is treated as what is good for democracy. There are different authors that have worked with these items. And what we were doing is to use these responses to try to classify students regarding an ideal. So we were following the work from 40, and he used a latent class model over ICCS 2009. And he fitted a 5 latent class, and one of his latent classes was a group of students that would identify all the good things for democracy or things that enhances a democratic system, and they would highly also, or they entirely would reject all the situations in which there was a threat for democracy. So here we're just like hiding in white or leaving in white what are the ideal responses out of this latent group. And we're going to recode the original responses into this way. So if we, for example, if we created a sum score with the recoded variables, then we would say probably, I don't know, the students that are in the high up of the sum score, they're more likely to belong to this latent class that 40 found in the previous study. So the following code is what it's going to do is to first to create two like short functions to do reassignments of original values to a dichotomous option. So originally the values are from 1 to 3, and we're going to assign them in a specific pattern. So the first recording function is going to be 1, 0, 0, and the second recording option is going to be 0, 0, 1. And then we're going to apply each of these functions of recoding to create new variables, and then we're going to save those. And by saving those as a specific object, then we can merge them up as many times as we want to with the original data frame. So what we're doing is to create a specific data frame for a specific model that we want to build up at the end of the code. And finally, once we have the data that we need, so in this case, let's say that we just want to create a population average model using a latent class to replicate the 40's studies, but over ICCS 16. We only need the survey design variables. So these are here. And we already have the items or the responses that we want to analyze. So we can just join them. And once we have them joined, we can export them to the statistical modeling software of choice. This could be either Stata, could be M+, or could be Latent Gold. And if we wrap everything up, so we're just using two code files. One is just this file that is called import data, that is going to take all the files and create a single object, and then the file of preparing data that is going to create the merge files, and at the same time is going to export the data that we need for the statistical model that we want to feed at the end of the exercise. And if you go to the workshop website, you can download the critical files to try to replicate this entire process. And to replicate this entire process, if you have R installed and you follow the instructions of installing the critical libraries, you should be able to just execute this first file and the second file and produce all the results that I have just showed you as an entire workflow.
Can I ask a question?
Yeah, go ahead.
I just forked your repository, but I cannot find like the folders 0, 0, 0, 1, whatever. I can only see like session 3 and like R Markdown files with the structure or the equation models. So,
no, they should be in the README file. And in the README file, I mean, you don't need to clone, for example, the repository. If you just go to the README file, in the README file, there are specific links to each of the objects.
Okay, thank you. I'm going to see.
Okay. So this is the end of the first session. Should I just go right away to the Latent class one? Okay. So give me a sec. Okay, so now, in contrast to the previous presentation, which was really focused on the coding, the current one is going to be a little bit more conceptual. But we're going to use as a bridge the same case scenario. So we were working with UNESCO to try to establish a threshold to say if students were more likely or more able to endorse ideal features of things that are good for democracy and things that are bad for democracy. And the issue was that the traditional way to do, or at least for the rest of the instruments that we were working with, the partial model was enough. Was enough to just to separate the students between the responses and to make an interpretation regarding if they were like closer to the ideal of the SDG indicator. Whereas with the case of these items from what is good for democracy, it wasn't the case. And given that there was previous literature that already used mixture models, we were tempted to try out this approach to see if this would be useful for the purposes that we had. So for starters, the main issue with is to understand what is a latent class. Latent class is just a different latent variable that has a different shape. So most of the most common approaches from latent variables, they conceive latent variables as a continuous term. And this includes IRT models, confirmatory factor analysis, and multi-level models. All of those include latent means that has a continuous shape with a normal shape. Mixture models, what they do is that they try to retrieve random terms, but they do not have a normal shape. They would have only locations and some other restrictions. So the most liberal model is the unordered latent class that is trying to retrieve unobserved categorical groups out of a set of observations. Probably the other kind of a statistical approach that is out there that's kind of similar or akin to the process that latent classes are trying to resolve are cluster analysis. But the main difference between latent class models and latent profile analysis is that the latent class and all the mixture models, they have they come from a probability distribution. So that means that you would have fits, that you can compare models, that you would have residuals, and so on. This is not something that is easily resolved for the case, for example, of k-means distance in cluster analysis, in which it's pretty difficult to compare different solutions. Whereas in the case of latent class analysis, you have access, for example, of the information of the log likelihood of the model and different other fit indicators, so you can compare two different choices by adding more parameters or leaving out different parameters. In the big scheme of things, there are more models. So on one end, you can conceive, for example, IRT models or confirmatory factor analysis. And on the other end, you can have latent class models. And in between, there is an array of other different models that are going to mix up this different choices. We're not going to talk about those, but it's good to know that they are out there, because once you are within the latent class analysis, it's really difficult to not to think about mixing up or instrumenting a latent class for a specific purpose. So we're going to discuss at least 3 applications that I know regarding how to use a latent class for a specific purpose. One of them is the use of using latent class analysis to express the theoretical notion of the long survivor. For example, in a student dropout, if you compare the life table of a population of students, you would observe that there are many, many students that don't drop out of the trajectory of entering from primary school to the later stages of secondary school. Those cases that never drop out, so that they fulfill the full trajectory, they tend to be called long survivors. This comes from the idea of biostatistics, that when you're applying a survival analysis over a disease, there might be cases that are immune to the disease, so they are not at risk of dying. So if we apply the same idea of long survivors to students, is the idea that these are the students that will not be at risk of dropping out. What Catherine Massin did was to use a latent class model to approximate the notion that, that some students may not drop out. The cool idea of this approach is that when you ignore for example, the students that don't drop out, all the relationship with your covariates are going to be underestimated. And if you're, for example, assessing program evaluations regarding how to retain students or how to retain teachers in schools, it might be the case that your program evaluation would be underestimated, and then you may commit some sort of error regarding your recommendations. So Catherine Massin is using latent class analysis to implement a non-parametric file tree to correct hazard estimation. So this is one application in which you use a latent class for a specific purpose and to have a substantive interpretation out of your data. So the main point of this example is to say that latent class are not just like something that comes out of the data as something, I don't know, like a random property. Is that you can use this kind of model to represent a specific ideas that are useful within social science, especially in education. The second example is the work from Torres y Ribarra and Dayaco, in which what they did is that they use latent class analysis to approximate proficiency levels. Most of the time when you take up an IRT model that represents a test and you want to say that, I don't know, such and such students are above the benchmark and the other students are below the benchmark, you will need to get together with a set of expert judges. And the expert judges, they would need to tell you what is high achievement, what is medium achievement, and what is low achievement. And they will need to reach a consensus regarding this classification of the student responses. And most of the time they would do that even without the information of the empirical data. What they propose is to use latent class with a really specific constriction in the model to try to find how many levels are tenable given the distribution of responses. So this allows you to say that if it is feasible, that you would have a continuous score, and then you would say, okay, I'm going to classify all my students between 5 different levels. So they're going to be the ones that are really, really high, the ones that are kind of in the middle, the ones that are really in the middle, and then 2 other different classes of low achievement. The model that they are using, it allows you to test and to assess if having 5 levels is feasible. And the most likely scenario sometimes is that if you don't have enough reliability to separate students, 5 levels is too much, but 3 levels is enough. And for the case of the students, for example, I don't know, classifying students between proficiency levels in teams, that's not necessarily difficult because you would have many, many items, but it's an entirely different deal when you want to classify, for example, teachers regarding their professional performance, because you wouldn't have as many items as you would have in an international large-scale assessment. And finally is the example of Quaranta, that he used a latent class analysis and an ordered one to represent the pattern responses of the students and to say what kind of how to use a typology to represent how a student thinks about what are the ideal features of a democratic system. And this is the example that we're going to talk about. So I would say that in summary, what are the main or three examples in which it is useful to feed a mixture model is when the model can provide you information that the other model can't. And this is the case for log survivors, for serial-inflated models and ceiling effects, especially when you have a categorical like hypothesis. So this is great with proficiency levels as ordinals features, or when you have a typology diagnosis, for example, when you're using indicators for classifying diseases. And they're also especially applicable when once you see the results that this makes sense. The most problematic application of a statistical model is that you finish, you see your table, but you cannot explain anything. That would be like a really good test that it might be that even if your model gets like a really good fit, if you cannot say a substantive interpretation with the estimates, then I would say that maybe it's not the right it's not the right tool for the question that you have. So this is the question. This is the set of items that the students were answering. And the main problem that we have is that we took all of those, we scored them in the direction that we needed to. And once we apply a partial credit model, the reliability was really, really low. So it was 0.78. So even if we could build up an item person map that would say what the scores that we created, how they match with the response pattern of the students, the item person map what it's telling us is that there is not so much difference. So that means that there is not like a qualitative difference between the students that are in the right side of the threshold and the students that are in the left side of the threshold. They're two, they're not far apart. It would be too arbitrary to make this distinction to try to say that these are students that are closer to the ideal of the SDG indicator. So what we did then was to use the idea that this complex class exists. So that there is a set of students that above all tend to identify correctly what are the main threats to democratic system and what are the good features for democratic systems. So we recode the original responses following this pattern, and then we reanalyze the data to see if we can find the similar patterns that Quaranta found in ICCS 2009. Then we have two different choices to compare countries. The first model is what is called the structurally homogeneous. In the structurally homogeneous, you allow that the countries can have a direct effect over the latent variable, but not onto the indicators. This assures you that the response pattern per each latent class is common. So when I found, for example, a student from latent class 1 in country A, and then I found a student from the same latent class in country B, we're talking about the same response pattern. There is a second approach to model responses between countries, and it's what is called the partially homogeneous model. In this one, you allow that the country not only has an effect on the rate of the latent class, that it has an effect of each of the indicators. What we argue with one of my colleagues, Torres Ibarra, is that this approach, instead of it be calling the partially homogeneous model, should be called the country-specific model, because what it's going to give you is a model that is really specific to the country. That would make you, for example, let's say that you want to, I don't know, use a model to identify or classify diabetes. That would mean that if you use this model, the diabetes type from country A would be different from the country B, because the model is allowing you to create different patterns. So if we, one way to show this difference is to fit the expected responses out of the two models. So in the thicker line, we have the homogeneous model, in which the expected pattern of responses cannot vary between countries. In contrast to the partially homogeneous model, in which each country can have its specific expected response. So that means it's like the countries that are closer to the thicker line, they tend to be more similar to the homogeneous model, but there are several countries that they are too far apart. So the issue is that once we generate the latent classes to make inferences, we cannot say the same thing for country A and country B. And the same thing happens with the latent class, the minimalists. So the minimalists are the students that, when they were asked what are the ideal features of democracy, the majority of them, they would support that electing political leaders and supporting same rights for all are the main features. Whereas the rest of the features, this kind of a student wouldn't present like a high endorsement. And finally, the really limited students that they tend to not to endorse any of these ideal features of a democratic system. This is more or less the response distribution for the homogeneous model for the 24 countries. And what we end up arguing for the work that we were doing with UNESCO is that the complex class are the students that are closer to the ideal of the sustainable developmental goal. Whereas the other two types of students, they do not fulfill the idea of endorsement or identifying the ideal features of a democratic system. So this is just an example of how these models can be fit and specified in two different software. One of them is Latent Gold. So the first part is the settings that you may need, that you could use to include the survey weights within the estimation. And then in the second window is the structural part. So the main issue here is that the equations from Latent Gold express the latent diagram in a really direct way. So what we are saying is that we have a latent variable called class, and it has 3 groups. And only this latent variable conditions each of the items. This one there is just to express that you're going to have an intercept within the equation, and that countries can only predict the rates of the class. So the country doesn't have an effect over the items in a direct way. It has an effect over the items, but only in an indirect way through the latent class. If we want to do the same model or partially the same model with M+, M+ uses a different parameterization. What M+ does is that you could use so you can you can conceive the country as a latent group, but as an observed latent group. And what it's doing is to feed a multi-group latent class analysis. You would retrieve the same expected responses that you can get from Latent Gold, but you would have more parameters in the approach that M+ is using. And so in this section is where we are putting the information to include the survey design. And in this other section, we need to declare that the items that we're going to estimate a specific intercept item per class per group. So if you have 24 groups and you have three latent classes, that means that you need to write one of these per each group. So you would have as many lines such as this one per each country that you're including in your analysis. One of the main issues with latent class analysis is that you need to build up an argument of why you came to the conclusion that this solution is the best one among any other alternative. And this is the problem of model selection. There are many judgments that you can do, but most of the implementation requires that you would feed the alternative models that may compete with the solution that you're choosing. So in our case, we feeded different models from 1 to 10 latent classes, and then we compare the feed indexes out of these different model choices. The main feature that lead us to select the 3 latent class is that the overall feed was good enough to represent the response pattern of the model. So we have a non-significant p-value, which means that this is applying a chi-square over the full pattern of responses. It's like a really big table, contingency table. And what this is telling us that the specified model that we are using is enough to reproduce the contingency table that we are applying. So we end up saying, okay, this seems like enough statistical evidence to defend the 3 choice. If we compare with the with only the 2 latent classes or with the 4 latent classes, you get, in the case of the 2 latent classes, you lose a lot of information. In the case of 4 latent classes, you only retrieve like a really small latent class that seems reversible, and that is pretty similar to one of the previous ones. So you're not getting much more information. And the main point for our purposes is that we wanted to identify, we wanted to have a reasonable method to retrieve the complex profile of students. We didn't have a substantive interest regarding the rest of the latent classes. So for our purposes, the 3 latent class models seems to be enough and defendable for the task that we were trying to do. So a few final remarks for the people that may want to use latent class models over large-scale assessment. Latent goal is really quick. I would recommend to you that you would use it if you have it on hand. N+ is really slow, but it has an advantage over latent goal, is that you can create code that uses R to feed many models and to retrieve the results using code in an ordered way. So you don't have to be copying and pasting estimates from tables. The new versions of M+, they have optimized the timing of the estimation for latent classes, but you may need to fiddle around with the options to get the advantage of this speeding process. But in any case, if it's not an effort for you to get a hold on latent goal, this is the safest bet. It's really quick. It's about, I don't know, like 5 minutes per model, whereas in the case of M+, it could be like 6 hours to 70 hours, to 27 hours or more. And at the end of the presentation, I'm including a selection of annotated references so you can consult further more information regarding this kind of models.
Okay, it's my turn. Can you hear me pretty well?
Sorry.
Yes.
I have a question about, should I wait till the end or about latent class?
Probably now is better, no?
Yeah, I think so.
Yeah, because I have a concern, a personal concern, because regarding the multi-group analysis in Latent class, if there is an order to test the homogeneity, first starting with the homogeneous model and then the partial, because I'm having a problem that the best likelihood is not replicated, and I don't know if that is related to this. I don't know if you can help me with this.
Yeah, I mean, if the log likelihood is not being replicated, that means that it's like not having a proper solution. It's like you would have more than one solution to the model that you're feeding over your data. So this is like a really big threat for the structure that you're trying to compare with the observed data. If this is the issue, I would try to discard all the other sources that could explain why you cannot find, because you need to find like a local maximum. If you have more than one, then the model doesn't know where to stop. So one way is to check if you have sparsity. Sparsity is when you have a few cells that doesn't have enough information.
Yeah.
And so you may need to discard that a few of the categories of responses are available for each of the countries. If this is not the case, I would recommend just to collapse a few of the response categories, as long as you can still make a substantive interpretation of the recategorized data. The other option might be to change the algorithm, but that could be more cumbersome. Let's say that you can, that the main point of the argument is not regarding the survey design. So if you leave the survey design on the side, because maybe it's not the main point of the inquiry, you may have different choices of estimators, and one of them is a non-informative Bayesian model, and that may help in terms of speed, and may also help in terms of the non-replication of the best log likelihood. Those are the two, at least, choices that I would try to do.
Okay, but it is not related in any way with this multi-group analysis, because it happens when I perform that.
Come again? I didn't understand your question then.
No, I'm just asking if it's not related with the multi-group analysis, like if the constraint of some parameters maybe are complicating the analysis.
I would say that the main, my first suspicions would be that if is a sparsity, is a sparsity conditioned by several groups. Because, for example, let's say that you have 10 countries. Each of the 10 countries is going to provide you 5,000 cases. The most likely scenario is that you would have observations in any of the cells of the contingency table. But if you separate all the countries and you feed the same model repeatedly over the 10 countries at the same time, I would bet money that you may have some sparsity in at least one of them in one of the categories.
Okay.
So that's why most of the examples of latent class, what they do first is to do some sort of recategorization of the variables. So they would start with an original set of responses that may have, I don't know, categories from 1 to 4, but when they feed the model, they do it over recategorized response data of only 2 categories. And this is a way to avoid the sparsity.
Yeah, I'm working already with binary data, so I don't think that is the issue.
Okay.
Yeah, but
these are the only 2 options that I can think of for now.
Yeah, I will check it again. Thank you.
Okay, and I have a doubt about the time. How much time I have in order to, because I worry about the finish of the session.
We have
are,
until 7:30.
Okay. Okay.
so we have half an hour.
Pretty good. Yeah, yeah. Thanks again for the invitation to INVALSI conference. I'm pretty happy, very happy to participate in this year. I prepared a presentation about the structural equation modeling. Let me check. Yeah, this is a presentation that have three moments. The first moment is a very brief theoretical foundation about the structural equation modeling and its applications. I will try to go in fast in this part because in order to go into the examples in the second and third part, I prepare an example estimation of confirmatory factor analysis, and in the second part, using the same scale that I use in confirmatory factor analysis, I use a structural equation modeling in order to predict these latent variables that I estimated in the first part of the example. Okay, about the general issues about the structural equation modeling. It's very important to discuss this issue about, and the most important application of the SEM is about the measurement issues in social science. The most part of concept attributes or controls that we have and we can observe in the social science are latent, and it's very difficult to observe in the real life. Typically, we observe in a manifest ways using indicators. That is the logic that we use in the most part of surveys. When we ask to people that answer some items, we are trying to observe some specific behavior that is an indicator of a latent issue, a latent concept. And in that way, we try to, and we need to construct better measures with less error. And if we have better measures with less error, we have better instruments. That is the main approach that I use, and we can read in different texts about the application of structural equation modeling in social science. And that is the most important logic that we will use in here. And how to diminish the measurement error. Most part of the time we have to deal with the error because we have a lot of sources of error, and that is the most important or the most threatened to the measure that we use and the models that we made. This is the approach about the total error, in which we can observe, for example, we have two main sources of error: the representation, and in which, for example, ILSAs, the large scale assessment studies, try to control it using, for example, very good samples in the different countries. But there is a lot of problem with that because the difference in countries have a lot of problems and huge variation across countries about how good is the sample, about the target population, for example, the clarity about that, the possibility to define the population inference, the sample frames is very, very different across countries. For example, Latin America, we have a lot of problem about the sample frames. And after that, when we go to the schools, sometimes the schools don't exist, or the student doesn't exist inside the schools, or the number of students change from when we create the sample frame and after that. And when we collect the sample, there is a lot of problem of time because some student doesn't assist, and the absence impact on the sample that we collect in the final part. And the respondent have a different approach to the questionnaire. And in that case, we have a lot of different moments in where we increase and increment the measurement error about the representation issue. And in ILSAs, we can observe that. It's not the same, for example, when we observe the typical social surveys in where they take care about the representation, but they take care less about the measurement. And in the measurement track, we can observe another different sources of error. For example, here about the measurement, we can define properly the construct. That is the most important thing, I think, because if we can make a very good definition about the construct, the latent construct, we can make a very good content in the operationalization. We can create very good items. We can select the items that will represent these latent measures. But we don't know. The efforts are not enough, I think, in here, because the measures all the time have problems in this relation between the operationalization and operationalization and the construct. For example, when we use ILSAs, we have only some set of items in order to represent a construct. And sometimes this set of items is very limited in order to represent our construct. And in that case, we have to deal with that. But we have the same source of error about the measures that we will use. And after that is the measurement in the response, depending on the scale that we use and decide. And if we use as a continuous variable, as a categorical variable, as a binary variable, in all cases, we made decisions that could impact on the measurement error about the construct. And after the response is the same, because students and the process of the information have a lot of variation across countries, for example. And in that case, we will have a lot of or difference across countries about the processing error. And in that case, yeah, this figure is only to discuss about the different sources of threat in order to make our estimations. And in that case, we can use the different techniques that are available in order to deal with it. And the structural equation modeling is one tool or set of tools in order to deal and try to decrease the sources of error and try to modeling statistically our data. And as I say, the latent variable is not directly observed, it's just latent, as is hypothetical, and we can hypothesize their existence using direct information from the item that we can observe, from the indicator. And the most common approximation of this about the measure issue is when some set of items have a correlation among them, then we can interpret this multiple correlation between some set of items as a common factor. That is the most important approach. That is very old approach about this kind of measurement issue in order to capture latent variables. This is based in the classical field theory, in where we can interpret this multiple correlation as a common variance, as the true score, and the other part is the error variance. And in this case, we going a little bit difference, because not only now the common correlation is the separation of the variance could help the interpretation in order to separate the true score and the error score. And in that case, we can observe our latent variables with these tools. Okay, what is the main part of the information? What is the factor analysis? This idea of common factor is a set of methods oriented to explain the correlation among variables, which could be interpreted as a latent variable factors. The existence of a common factor could explain the association among indicators. This is the typical conditional dependency assumption, in which if we partialize the existence of a latent variable or a factor, then the correlation that we can observe between or among indicators would be zero. And in that case, we can interpret our existence of correlation as a common element that could explain their existence, their associations. And this is the main approach that we can use in order to interpret and measure our latent variables. And why this is important? Because yeah, will allow us to observe these issues that we can observe. We cannot observe directly. Just we can observe indirectly through the specific items. And the purpose, the general purpose of this approach is we can watch three main purposes. In one side is reduce the complexity and increase comprehension of the issues. For example, about political participation, there is a lot of indicators that can show different behaviors about political participation, and there is at least 30 behaviors, and some behaviors are more related between each than others. If we can observe only by separate each by one, the complexity will be huge about how to understand the behavior of people. In that case, we can use this kind of approaches, this kind of reduced complexity using the structural equation modeling or factor analysis in order to increase comprehension and simplify the reality, because in any other case, it's very, very difficult. Another purpose in which we can use this kind of approach is to validate scales and increase evidence about the scales that we use in order to measure different constructs. Because these techniques or this set of tools have a lot of elements that can be used in order to provide evidence about the validity of the scales, how it works, how comparable between groups is, the set of items that we select in order to measure some latent variables are all we can use all items in order to measure this latent variable. We can select some of it in order to explain in a better way our latent construct. These different elements helps in order to validate or increase the evidence in order to validate from the scales. And in a more specific or more technical issue, the purpose is to separate the common variance and the unique variance. That is the more technical and more practical way in which we can understand the purpose of the common factor approach. General foundations are based in the typical statistical basis: covariance, correlation, partial correlation. Mainly the most part of elements that we can observe in the structural equation modeling tools are based in this idea. It's very important to understand this in order to apply this kind of techniques. Based mainly in simple and multiple correlation. It's very, very easy when we can understand the most part of elements and the parameters that we can observe in the structural equation modeling when we think as a simple or multiple correlation, because mainly are correlation and partial correlations more part of the time. And because of that, we can consider the general assumption of correlation in order to understand the linear approach of structural equation modeling. Of course, we can find variation here. For example, there is a lot of development in categorical approach in order to use these techniques, structural equation modeling using categorical data. But in any case, there is some corrections about the properties of the matrix, on how to build the matrix, based in linear correlation or based in the polynomial correlation, for example. In any case, the matrix are based in the typical assumptions. This is just formation, the assumptions. We need at least interval measurement level. This is very difficult in political science. Overall, when we measure attitudes all time or behaviors, It's different when we measure knowledge, but in that case, it's other set of techniques that apply in there. Normality of the indicators, that is very hard to get, and sometimes we can make some corrections about that when we doesn't have this kind of assumption. Linear relation among variables, that's a very important assumption about in this approach. The correlation or the association among variables must have certain level in order to make its aggregation. And there are some rule of thumbs about the sample size. For example, we need at least 200 cases. With less than 200 cases, we will have a lot of limitations about the complexity of the model, for example, or between 5 and 10 cases for each variable. But this is our only rule of thumbs. And we will have another problem when we have huge samples, because the most important indicator of fit index, the chi-square, is very sensitive to the sample size. And in that case, all time we will have some elements, and we will have to observe the sample size. It's important to discuss. Just for discuss very quickly the typical representation of latent variables or structural equation models. When we represent a latent variable, we can observe an circle or an oval. That's very common and is common language today about how to make this representation. The observer variables or indicators are represented as square. The unidirectional path or regression path we can say as a line with a arrow in one side only. We can represent the disturbances about one latent variable in here, or disturbances or measurement area about the one observer or observed value, and the correlation or covariance representation. We can observe as a line or as a middle circle line with arrow in both extremes. This is important because not all time we can watch the diagram, but this is a kind of discussion that all time we can find in the different textbooks. About the measurement issue by one side, and here we can find at least three, or the main three techniques or approaches in the context of a structural equation modeling or latent variable approach. The principal component analysis is not exactly a factor analysis. That is a big discussion between some people about if this is or not a common factor approach. But the main characteristic of it is the definition of a common component from a linear combination of variables. And there is some difference from the other two approaches. The exploratory factor analysis is a descriptive technique which allows to determine the number of latent factors from a set of indicators, separating these common and unique parents in order to create one indicators. And the common factor analysis and the complementary factor analysis, is a technique which allows to hypothesize the existence and hopefully confirm the existence of a latent variable, specifying a set of parameters. How we can compare this in a representation way? We can observe the principal component analysis. The line is from the indicators to the principal components. It's a linear combination or average, weighted average. That is the typical way in which to approach the principal component analysis. And the main difference from the representation of exploratory and complementary factor analysis is the direction of the lines of the association. For example, in the principal component analysis, the direction of the line is from the indicators to the principal component. But in the factor analysis, it's the direction of the prediction is from the latent or the factor analysis to the indicator. In this case, the existence of the factor explains the association between each indicators. And the difference between exploratory and confirmatory factor analysis is the parsimony of it, because in here we explore and describe the existence of factor analysis, but it's not so clean because there is cross loading in here, and in any case we will have some cross loadings between indicators and factors. But in the confirmatory factor analysis, we decide which is the model, and in here is very parsimonious way in which these indicators x1, x2, and x3 are related because of the existence of factor 1 and the variable x4, x5, and x6. The correlation is explained by the factor 2. And that is our hypothesis. And we can test that hypothesis in order to check if this model works or don't. Let's see. That is the main question that we can use. In here we can replace the number factor as a latent or dimension, but that is the main idea. And beyond the measurement issues, we have the structural issue, or the structural equation model, of full structural equation model, in which we will have the measurement model part that we can observe the existence of the factor 1 is explain the association between y1 and y2, but after that we can put in relation the factor 1 and factor 2, the latent factors. And in that case, we will have the full structural equation model. This is only a representation because we have a lot of options. For example, this is a full structural equation model, only latent variable explaining between each. Or for example, we have another option in where we, in a first step, we evaluate three latent variables based in this observed indicator and its association between each. And in a second step, but this is happening only in one step, in one estimation, we can use observing indicators to explain these latent variables. Another option that we can use in this case is, for example, latent variable predicting observing indicator. That is another way to think this. And in here we can, as we can see, it's not only a regression. In here we have more complex association. For example, this is a kind of mediation analysis in where poor physical health is connected with poor psychosocial health through personal mobility. This is an example that we can find in Baujan text about the structural equation modeling. And the other option is path analysis, where we have only observed variables and we can make a relation about that. And what about parsimony? Because this is, for me, is very important, the idea of parsimony, the idea of simplifying the reality. And after simplifying the reality, try to explain the relation between different elements and try to simplify the measures because we have too much complexity in reality. After that, we can observe models like this, in where it's very, very difficult to follow what is the relation, the relevant relation about different elements. This is a growth modeling between different variables in 3 times related between each, and using latent variables approach. It's just for saying all time, we have to keep in mind all time the parsimony in order to explain, because for me it's very difficult to diagram a kind of a picture like this and explain after that what is the relation, the main important point about this. Okay, about the estimation process, I'm going a little fast about this part. We have some step in order to estimate CFA and structural equation modeling. And in our first part is the model specification. This is the most important part for me, and try to transmit this idea. Is the moment in when we think about the theoretical relation, about the latent association, about the construct that we will use, and how this are over-rationalized. This is the theoretical moment and the model specification. What will be the hypothesis that we will put in the model? And after that, we can take the data and the most part of elements, practical elements. But the theoretical moment is very important in order to put which will be the model that we will test. After that, we need to check the identification of the model. This is a part mainly about we have enough information in order to make this estimation. For example, we have enough indicators in order to estimate a latent variable. We have enough information. We have enough cases in order to make our estimation. If we have enough information, we can follow in order to make the estimation and evaluate the adequation of the model. If we don't have, we need to think again. If this is the proper approach in order to make this. And when we estimate the model, when we make the model specification, we need to check the adequation of the model. If our hypothetical model found evidence in order to, using our data, in order to confirm or unconfirm our hypothesis about the measure or about the relation between latent variables. If the information about the adequation, if we have information in favor about our hypothetical model, then we can interpret the estimate. In any other case, if we don't have information about the adequation of the fit indexes, the interpretation of the estimate is poor and spurious sometimes. Yes, and after this, the interpretation, we can consider another options like equivalence between the model comparing, for example, between groups or across countries. That is another kind of questions. And finally, report the results. Then today we will go step by step about this, expressing the hypothesis and equations. That is the first part of the estimation of the process. I will discuss a little bit about the one hypothetical model that I work for some years now in my doctoral studies. I use this approach, and after that I will show a little bit about the estimation process using R and using M+, and explain a little bit about this. And in order to estimate each hypothesized parameter and interpretation of the fit indexes in order to evaluate if the hypothetical model works or don't. And after that, I will show a little bit about the report. Okay, a little bit about hands-on. Only saying a little bit, you can find in the link that Pamela shared with all an HTML report in where you can find the example that I use in this presentation. In order to replication, you can find the data, the codes, and the results. If you want to try another things, and if you have, the only important thing is you need R and plus both of them, because this session is based in both programs. I will speak a little bit why we still using in plus if we have some free software like R, for example, and Laban, which is the package in where we can make the most part of analysis that we will show now. Okay, the first is the example of CFA. I will estimate this model. This is the real representation of the model. It's an three-dimensional model of citizen participation, youth citizen participation. This is turnout, because this is TUR, or voting behavior, or intention to vote behavior, based in three indicators. This is legal activist participation, based in 4 indicators. And this is illegal activist participation. based in 3 indicators. This is the more part of the hypothetical model that I will test using some data. Just an theoretical explanation or discussion about citizen participation. It's very, very brief discussion about the first part of the estimation. Here I will use the hypothetical model that I think for some time in order to capture the complexity of participation in youth population. And youth population have different problems than the adult population. For example, youth people, your student doesn't have the right to vote. Because of that, it's very difficult to measure formal participation in young people, people less than 18. In most part of countries, because in most part of countries, the legal age to vote is 18. We have only some cases in where it's 16, and we have other cases in where it's 21, even today. But this is an important issue because if we want to measure formal participation, traditional way of participation in young people, we don't have options because student doesn't vote in general, doesn't vote in national election, in community, local elections, or even doesn't receive information about the elections. Sometimes participate in some elections in the schools, but it's not exactly the same. Because of that, I think it's important to use future intentions to participate. In here, the intentions have a justification in order to use it. Another difference, depending on the age, is the opportunity to participate in activities. For example, are very limited. Depending, for example, at 12, the most part of the student doesn't participate, doesn't have experience in participating in legal or illegal participation. But at 16, it's different. The student will have different opportunities and options to participate. Because of that, again, it's just for justify the use of intentions to participate. And another element to discuss this is the different dimensions to cover different options to exert citizenship. It's a huge discussion about this, about the different dimension of participation. And in here, I will use, and you can read a lot of these dimensions. We have the formal part of participation, the relation with the state, mainly, how people relate with the state, mainly through voting or doing membership in the parties, for example. And other important part of the citizenship is the contentious politics. And in here, in the contentious issues, we can find at least one distinction: the legal part or the conventional part, a set of behaviors that are allowed to do in which students or people can involve, and the legal part, and that is another kind of behavior in which people can involve. Just for saying, this is the model that I will test. Three dimension of participation observed with 3 indicators for formal, 4 indicators for legal activities, and 3 indicators for illegal activities. And just an explanation of the data, it's International Civic and Citizenship Study 2016, and merged with the National INVALSI evaluation. This allowed 2 elements. For example, in the first step, the evaluation of the model that I showed right now. And in a second step, we can evaluate the relation between specific variables and its impact on young citizen participation. For example, they evaluate how reading skills impact on participation. There is some line about that, some development that in which I participate with other people, try to discuss how the reading skills, this kind of specific skill which is developed in the schools, could impact in citizenship. And there is some literature about that. In order to evaluate formal participation, when you're adult, what do you think you will do? This is 3 indicators. You will think you will vote in both in national election, local election, and get information about candidates and the probability of do that. And you need to pre-code these scales because it's in the reverse. And about the activist participation, legal and illegal, I will use the first four elements. I use only these first four because the other elements are related to online issues. Because of that, I use the first four. Talk to others about your political views, contact your representative, take part in a peaceful march or rally, and collect signatures or petitions. This is very traditional way in which to measure the conventional activists. And unconventional or illegal activists, I will measure using these three. The disposition to spray paint, protest slogan on walls, protest blocking the traffic, and occupy public buildings. Using the Italian sample. Okay. Now I will combine the part of the code, and in the first step we can observe the mean, and for activists the mean is very low. For formal activists or legal activists is in the middle, and for formal participation is little bit high. And that is just for description of the data. About the correlation, this is a way to explore the correlation, but I will show the graphical way to explore the correlation. And in here we can observe, for example, the activists, the illegal participation have higher correlation than between the others, and the peaceful participation have higher correlation between each, and formal participation higher correlation than with the other. And in here we can anticipate the good works of the measurement model. This is the way in which in M+ we can create in R we can create the M+ syntax. We use this code in order to create the M+ syntax. We recreate the M+ syntax in the M+ tournament and tournament. In where we can find the title variable. In here we can specify the design, cluster, ID school, certification, Jackson's, weight, total weight, type of analysis, complex. In here we can specify the three latent variables. Turnout by the three formal variables, indicators, legal activities, and illegal activities. And this is the code to create the model in M+. This create the input file to M+.
Daniel,
yes.
Just to say that we are over the time now. We have been granted another 15 minutes to finish. I assume it's going to be enough for just to give you a heads up.
Yeah, thank you.
And the participants, of course, just for you to know that we're close to it.
Very well. And this is a picture about the input file syntax in M+. This is a picture of the M+, and how it's created by R. Okay, just for saying. After that, in the final part, I will show a little bit about how is in the input and output file. And we can made a representation using the SEMPlots, basically in the SEMPlots package, which take the model that we specify, and here we made the representation of the model. It's very easy because we don't have to draw line by line. This is an automatic picture of the model. Just for the output about the result, this is the descriptive, univariate descriptive information is exactly the same that we can observe using R, but now is basically in the output file of the M+, and we can observe again the same pattern in where the mean of the activist but illegal participation is lower, middle in the legal participation, and the higher in the formal participation. What about the evaluation of the model? And in here we have to observe the output file in M+, and in M+, we will have a lot of information about the fit indexes, The most important elements are three: the chi-square test of model fit, in where we can observe the test of chi-square, and the interpretation is high value, poor adjustment. And the null model is that the matrix that we estimate based in our hypothetical model is very close to the sample matrix. And in this part, we don't want to reject the null hypothesis. And what happened here? The p-value is very, very low. The probability that these two matrices, the hypothetical matrix and the real matrix or the sample matrix, are similar is very, very low. In that case, we rejected in the hypothetical, our hypothetical model. And that happened a lot, this part, because chi-square is very, very, very sensible to the sample size. In this case, we have 3,000 more cases. Because of that, was developed a lot of or different fit indexes. Here we can observe the comparative fit index, the CFI and TLI, and which interpretation is, if closer than 1 is better, and the cutoff point is around 0 or 0.95. That is the typical agreement about which is the cutoff point. But we can observe in different publications, we can observe a little bit less, but never less than 0.90. That is the real cutoff point. It depends on the complexity of the model. And the other indicator is RMSA, in which case, when it's closer than 0 is better, lower than 0.05 is considered a good model, and less than that is a better model. It's a kind of parsimony correction. And in this case, we have to report and interpret the three elements. The CFI higher than 95.95, TLI higher than 9.45, in this case it's 9.23, 0.93, sorry. And the RMSA is closer than 0.5, okay? In this case, we can say that this is a good model. Maybe we can increase or improve a little bit, but it's a good model. And after that, we can make the interpretation of the loadings in this case. Standardized model results, the loadings of the turnout or formal participation are pretty well. Legal participation and illegal participation, and the association between these latent variables. And here we can observe the R-square, just to analyze which indicators could be removed but in that case we have another options. This is just one way to extract the information from R to M plus in order and show in the same interval. And in this case we will have the same information. In here, for example, we have the fit indexes information, the observations, the fit indexes, chi-square, and in here we will observe the factor loadings and the other information about the matrix. And just for saying, we can use as a slave the M plus from R. And the second example is just an improvement of the same model. We will use the same model, and we will explain the three type of participation by reading skills, gender, and education of parents. We estimate the model the same way, just create an M plus input file and generate the input and output file and estimations. And after that, we can extract the information, and what we can say here. For example, turnout is predicted by higher education. Higher educated pattern impact on formal participation, little bit on legal participation, but doesn't have a relation with illegal participation. What happened about Italy? The reading skills measuring the Italian evaluation of test. In here, the Italian evaluation test is possibly related with formal participation, is not related with legal participation, but is negatively related with with the illegal participation. Students that have higher skills of reading have less disposition to participate in illegal ways. That is my interpretation. It's just a way to interpret the result that we have in here. Some extension of this, we can use confirmatory factor analysis in order to constraints, equivalence, or measurement variance or equivalence across countries or across groups. Measurement model with categorical indicators, that is another approach in which we use this kind of techniques. And in the way to use structural weighted modeling, we can estimate mediation modeling or more complex model, multi-level structural weighted modeling. That is another way to use. And the longitudinal modeling, cross-lab or latent group, or the other options that we can find. Why we using plus? That's for clothing, because plus have the old element. We can specify the complex design. We can use the plausible values and the structural equation approach. That is not allowed for now in a Laman package or any other software that I know for free, at least, except in plus. That is my presentation, just for showing. You can find, no, it's okay. You're just for repeating, you can find the practice or the code and data in the files that we share. If you have any doubt, question or queries, you can write us and we can share information about this issue. Thank you very much.
Thank you very much, Daniel. And with that, we're going to close the session. We are over the time, but as Daniel said, please do not hesitate to send us any questions, comments that you have. Go to the GitHub webpage, try to replicate the code. And if you have any questions while doing that, please do not hesitate to contact us. Thank you very much for coming, and see you in the next following sessions.